Wheel alignment, or should we call it wheel realignment, is basic to the good roadability and handling characteristics of today's Chrysler Corporation vehicles. But unfortunately, the complicated appearance of the special equipment used for wheel alignment has often discouraged technicians from learning what is really a simple procedure. Actually, there are only 2 nuts per front wheel that can be adjusted. Add to that a simple tie rod adjustment, and that's all there is to wheel alignment.
What?
Okay, we'll admit there's more to the story than that. But those are the only adjustments you can make. So let's look at it that way and see what the wheel alignment man can do and can't. Of the 5 alignment factors, camber, caster, toe in, toe out on turns, and steering axis inclination, only camber, caster, and toe are adjustable. Toe out on turns and steering axis inclination are built in and are of concern to the wheel alignment man only as specifications in the steering system. Camber is the inward or outward tilt of the wheel from a true vertical. Negative leaning inward, positive leaning outward. Ideally, the wheel would run at all times with 0 camber. This would give the best tire loading and the best tire life. But in actual running, the 0 camber condition is seldom present. The wheel is continuously moving up and down, even on a smooth road. Also notice that the upper control arm is shorter than the lower one. This arrangement causes the wheel to go to negative camber in both jounce and in rebound. This action is important to good vehicle handling and roadability, and is a significant factor in tire wear as well. Camber angle is adjusted on all Chrysler Corporation cars by moving the upper control arm in or out. On all cars except Dart and Valiant, adjustment is made by means of a camber caster bar, which moves in slots in the frame. In Dart and Valiant, a system of movable cams allows exactly the same adjustment. Caster is the rearward or forward tilt of the steering axis as you look at it from the side of the car. The caster angle is positive when it is tilted backward at the top, and negative when it is forward of a vertical line. Caster is important in maintaining directional stability and also helps return the wheels to a straight-ahead position when coming out of turns. Caster is adjusted at the upper control arm at the same time that you set camber. Watch how this is done. You can think of the upper control arm as a triangle with 2 adjustable corners. If you move both corners in the same direction and the same amount, only camber is affected. But if you move only one end, a caster change occurs, as well as a camber change. But notice that moving the other end in the opposite direction will also increase caster, but will return the camber to its original setting. In actual practice, this is exactly how you set caster and camber. Moving either in or out one or both ends of the upper control arm. The only complication comes from the precise measurement of these adjustments, which we'll see more about later. Toe setting is the only other adjustment you need to make on a wheel alignment job. A slight amount of toe in is necessary in a car at rest to counteract the normal tendency of the wheels to toe out when the car is moving. Toe-in adjustment also requires special equipment. Steering axis inclination is the angle made between the vertical and the center line going through the steering ball joints. This angle is a design factor and is not adjustable. A variation from specification in the steering axis angle can only come from damaged control arms or other parts. Toe out on turns is the ability of the outside wheel to steer around a larger circle than the inner wheel. This action occurs naturally as a result of the lever angles built into the design. Toe out on turns must be correct to minimize side slipping and tire wear. We'll see how to check this later. There are a number of things to check on the car before any adjustments are attempted. Tires must be the same size and type and in good condition. If tires are worn, they should be switched with the rear tires if those are good. Inflate all 4 tires to the correct pressure and adjust the tank weight for a full tank of gas. Check and adjust the front wheel bearings. Check ball joints and all steering linkage pivot points for excessive looseness. Check the rear springs for uneven sagging and for cracks or broken leaves. And check the U-bolts for proper tightness. We'll use a typical alignment machine which will show us basically how all alignment equipment operates. However, be certain to follow the specific operating instructions for whatever equipment you may be using. Everything has to be zeroed before we begin. Be sure the ramp is perfectly level and that the front and rear wheels are carefully aligned. Center the wheels on the turning radius turntables and pull the locking pins. To obtain accurate readings, the car must be jounced just before taking each measurement: height, caster, camber, and toe-in. Jouncing is necessary to relieve any tightness that may be hanging up in the suspension. Front suspension height is measured as the first operation in front wheel alignment. On the Aspen and Volare, measure from the lowest point of the lower control arm inner pivot bushing. On all cars except Volare and Aspen, the height adjustments are taken at the torsion bar anchors. The maximum recommended allowable side-to-side difference in front suspension height is 1/8 inch on all car lines. Front height corrections must be made before any alignment is attempted, because front height will affect caster. Once you have the front height adjusted to service manual specification, install an adjustment unit on each wheel. This is a precise attachment which provides an exact extension of the wheel spindle. This gives you an accurate reference position for all camber, caster, and toe adjustments. You normally begin by splitting the amount of toe, putting 1/2 on each wheel. On this machine, the attachment projects light beams between the 2 wheels and makes toe reading simple. Turn the wheel until both wheels are recording the same toe reading. Install a brake pedal depressor to lock all 4 wheels, and again settle the vehicle by jouncing. All these preparations, and we still haven't made one check of camber, caster, or toe setting. But this precise setup procedure must be followed before any meaningful adjustments can be made. Now we're ready to read and record the starting camber and caster at each wheel. For this 76 Aspen, the right wheel camber is correct at 1/4 degree positive. Caster is read in a similar manner. With most equipment, the wheels are turned through a specified number of degrees, usually about 20, to establish a 0 point. Then turned in the opposite direction an equal number of degrees. The caster angle is then read directly and recorded. Turning radius, or toe out on turns, can be read at the same time the caster angle is checked. With the left wheel turned out to the 20-degree mark, toe out on turns can be read in degrees directly on the right wheel radius gauge. Here, it's right on at 18 degrees for the Aspen. Both caster and camber can and should be adjusted at the same time. Once you've recorded the starting caster and camber angles, you determine the amount of correction necessary from the data supplied with the alignment equipment. Remember that for camber corrections, you remove or add to both front and rear adjustments. You'll remember that way you change camber, but do not affect caster. Also, for caster corrections, you see that adding to the front and removing from the rear changes caster but preserves the camber setting. On all cars, you begin by loosening the nuts at the upper control arm just enough to allow you to force a change in position, but not so loose that you lose the original setting. The nuts can be kept fairly tight because the camber caster adjustment tool gives you plenty of leverage. Once you have the correct caster and camber, toe setting and steering wheel centering are done together in the final operation. First, center the steering wheel. With power steering, the engine should be running and the steering wheel turned from stop to stop and then halfway back before locking it in the center position. A good check of the power steering spool valve adjustment is to watch the steering wheel as the engine is started. Any movement or kick in the steering wheel as the power comes on indicates that a spool valve adjustment is necessary before centering and toe setting can be performed. With the steering wheel locked, loosen the tie rod adjusting sleeve clamp bolts. Adjust the sleeves so that you have 1/2 the recommended toe setting in each wheel. Recheck the steering wheel position for centering. Start the engine if power steering is used, then recheck the toe settings. Be certain to position the clamp bolts parallel to the floor before tightening to prevent their contact with the torsion bars on severe jounts. The ability to perform good wheel alignment is simply a matter of understanding the principles and getting a little experience in using the specialized alignment equipment. From both points, driver safety and customer confidence and satisfaction, wheel alignment is one of the most important service operations. We'll never stop customers from hitting curbs and chuck holes, but we can make a reliable diagnosis and perform an accurate realignment when they do.